Okay, this is 5.4. Factoring quadratic expressions in the form of x squared plus bx plus c. Okay, so the way we do this is you want to find two numbers that have a product and a sum. Okay, so we're going to start off with trying to find two numbers having a product of 12 but a sum of 8. Okay, so the first number we could say is 3 and 4. Okay, these would have a sum of 7, right? But they would have a product of 12. So that doesn't work. So 3 and 4 gives us a product of 12. Another two numbers that give us a product of 12 would be 6 and 2. So these two numbers, 6 times 2, give us 12. But they also, you see when they add, they give us a sum of 8. So these would be the correct numbers we're looking for, 6 and 2.
2 and 6, would that be different or not?
No, 2 and 6 also works. Yeah, same thing. Okay?
No, I'm saying like, could you do it again or it would be the same thing? Wouldn't it be different with the first
No, it'd be the same thing. 2, 6, 8. This also works, same thing. Next, we're looking for a product of negative 24, but a sum of negative 5. So you work with the product first, negative 24. So we know two numbers that multiply to give us negative 24 would be negative 12 and 2. So our first number, negative 12. Our second number is 2. If we add them up, we get negative 10. That is not negative 5, so that doesn't work. Next one, we could say a product of negative 24 could be negative 8 and 3, because when they multiply, they give us negative 24. So negative 8 and 3. The sum of those two numbers is negative 5. So these two work. Yep.
Is it just like trial and error?
Yes. Yeah. And I'm going to explain why we're doing this after, but let's just keep going. So product of negative 12. Okay, again, we can use negative 6 and 2. That would give us negative 12. That does not work though, because if we sum them, we get negative 4. Okay, we could do negative 4 and positive 3. This would give us negative 12, but it would give us negative 1 as the sum, so that wouldn't work. Negative 4 and 3, our sum would be negative 1. How about negative 3 times 4? Negative 3 times 4. If we sum those, we would get positive 1. So that would work. Last one here, product of 15 and a sum of negative 8. So 15, we know 3 and 5, right? So 3 and 5, if we sum those, we get positive 8. That does not work. But if we do negative 3 times negative 5, that also gives us positive 15. And if we sum those, we get negative 8. So that one does work. All right, so let's talk about why we're doing this. Many polynomials, such as x squared plus 7x plus 12, can be written as the product of two binomials of the form x plus r and x plus s. Does anybody remember what x plus r and x plus s was? Or why we've seen that before, Milkias? Yeah, it was the factored form for parabolas, and what did it tell you? Yes, good. Factored form for quadratics. And they tell you the x-intercepts. So we're getting into why are we doing all this, right? What's the point of all this? And the reason why for us is that if we can take something like this, x squared plus 7x plus 12, and easily rewrite it into something like this, x plus r, x plus s, well then we immediately know the x-intercepts without having to do a table of values, without having to graph. Okay, so that's the point of all this. Learning how to factor, learning how to take a term and break it up into its constituents, we can immediately find out what the x values are. That's the whole point of this whole unit and how it relates back to quadratics. So an analysis of the general expansion of two linear polynomials will simplify factoring x plus r, x plus s. So we know when we expand them, we get standard form. When we reverse that, we get factored form. Okay? So here we can see that b is equal to, if we're talking about this expression here, x squared plus 7x plus 12, we know b is 7 and c is 12. Right? So if that's the case, we need to find two numbers where the sum is equal to 7b and the product is equal to c, 12. That's why we're doing all this stuff up here. So now if we try to do product of 12, we can do two numbers. So let's say 6 and 2. That would give us 12, but it would give us a sum of 8. So that doesn't work for 7. We could do 3 and 4. That would give us 12, and that would give us a product of 7. So we know 3 and 4 are the two factors that we need. Okay, so our factored form would be plus 3 and plus 4. So do you see how now I went from this to this in one step by knowing the two numbers that multiply to give me 12 but to add to give me 7. Okay, and I can verify this if I expand this. I get x times x is x squared, x times 4 is 4x plus 3x is 7x, and then 3 times 4 is 12. So that's how I went from here to here. Any questions? We can do some more examples. This should start to make sense a little more as we do a couple more examples. It says factor check by expanding. So here we have x squared plus 5x plus 6. Okay, we need to find two numbers that that multiply to give us 6, but add to give us 5. Okay, so the first two numbers for 6, we like to maybe think of are 2 and 3, but the sum of those two numbers are 5. Okay, so right away, that works. 2 and 3, and we get 5. No, we're trying to get 5. The middle term. We're multiplying to get 6, but we're adding to get 5. So you're right. Max is 2 times 3 is 6, but we're summing to get 5. Okay, so then we know this right away can be broken down into x plus 2 and x plus 3. Right away. That's our factored form. Yep. Sorry? For B? I'm not sure. We're not there yet. Let's go there. 4 and 5. So what is going to multiply to give us 20? 4 and 5 works. And what adds to give us negative 9? So it wouldn't be 4 and 5. It would be, yes, negative 4 and negative 5. So it'd be x negative 4, x negative 5. Okay, and we know that because the product is 20 and the sum is negative 9. Okay, next one, D. We want to get a product of 10 and we want to get a sum of negative 3. So if we use 2 and 5, we get a product. Sorry, we want the product of negative 10. So we want 2 and 5, if we sum that, we get 7. But if we sum 2 and negative 5, we get negative 3. And 2 and negative 5 gives us negative 10. So therefore, our answer would be x plus 2, x minus 5. Yep. No, almost done. Okay, next one. X squared plus 2x minus 15. Okay, I'm going to show you now, actually going to show you a little bit more of a systematic way to do this. Because I understand it's sort of a lot of guessing, right? You can do this systematically by finding the factors of 15 one at a time. Okay, so here's how I've taught this in the past. So 15 divided by 1, right? This gives you 15. So 1 and 15. So you look at 1 and you look at 15. Is there any way I can get to 2 with 1 and 15? Positive or negative? Any way? No, I can't, right? Okay, so then I go divided by 1, so now I go divided by 2. So 15 divided by 2 is not a whole number, it's 7.5, so that doesn't work. So we'll go 15 divided by 3 is 5. So you can, is there any way to use 3 and 5 to get to 2?
Yeah.
Right, there is, right? Because 5 would have to be positive and 3 would have to be negative, and you get negative 3 and 15 gives you negative 15. So we know that these are the answers, negative 3 and positive 5. Okay? This is just a more systematic way to do it, where you have like somewhere to start. You can go through your numbers right away. Okay, so if we wanted to do it for this one up here, right? You could do 6 divided by 1 is 6. Can I use 6 and 1 to make 5? Yes, I can. But I would have to make the 1 negative. And that would give us negative 6, so that's not going to work. Right? You need positive 6. So you go divided by 2 is 3. Can I use positive 2 and positive 3 to make 5? Yes, I can. So your factors are 2 and 3. Not sure what's easier for you guys, doing it that way or using the table. But it's just another way to do it. So factor completely. So here, if I wanted to do it this way, I want to find out what multiplies to give me 24, but adds to give me, multiply to negative 24, but adds to give me 11. So if I start off with 1 divided by 1, I get negative 24. Can I use these two numbers to make 11? No. So if I divide it by 2, I get negative 12. Can I use 2 and negative 12 to make 11? No. So I divide by 3. Can I use negative 8 and 3 to make 11? Right? They both, in this case, negative 24 divided by negative 3. I can't actually use 3 and negative 8, right? Because they would add to negative 5. And if they were both positive, they would add to positive 11, but I wouldn't get negative 24. I would get positive 24.
Sure. Negative 6.
Negative 6 and 4, no. So actually this one, believe it or not, is not factorable. It's close, but the signs are off. Can't actually factor that one. That's why it says factor if possible. In this case, it's not possible. Right? If I went by divided by 4, I would get negative 6. I cannot use those twos to get 11. I would divide by negative 5. It's not a whole number. Negative 6 is 4. It does not work. Next one. This one is written out of order just to be tricky, so we're going to rewrite it to x squared minus 6x minus 16. Okay. Now 16 I could do divided by 1 is equal to negative 16. Can I use these two numbers to make 6? No. So let's divide it by 2. Can I use negative 8 and 2 somehow to make negative 6? Yes. So we would have 2, negative 8. Our sum is negative 6. Those would be our correct answers then. X plus 2, x minus 6. Sorry, 2 x minus 8, my bad. Any questions here? All right, last question. A rectangle has an area represented by this. Factor the trinomial to find expressions for the dimensions of the rectangle. So we need to factor this. So we need to find two numbers that multiply to give us negative 21, but add to give us positive 4. So we could do negative 21 divided by 1 equals negative 21. Can I use these two numbers to get 4? Divided by 2 is an uneven number. Divided by 3, we get negative 7. Can I use these two numbers to get positive 4 somehow? Yeah, I just got to make sure the 7 is positive and then 3 is negative, right? So therefore, x squared plus 4x minus 21 is equal to x.
Yeah, so that way it is in the story.
Yeah, it's easier, right? Because it's a system to it, right? You start with 1 and just go down. So those are our two factors then. And you could double check this, right? If you multiplied it out, x squared 7x minus 3x is positive 4x. Negative 3 times 7 is negative 21. Okay? Now it says calculate the actual dimensions if x is 50. So you would just sub in 50 for x. You would get 50 minus 3 and 50 plus 7. So you'd get 47 times 57. Oh, that would be the area, but it says actual dimensions, so they would just be 47 by 57 centimeters. Those are the dimensions of the rectangle, right? This is your rectangle. Okay, any questions with that last one? All right, I'm going to stop it here.